Hi, this video is about static and kinetic friction. Let's recall that friction is a force in physics that opposes the relative motion between two objects or their surfaces. One type of friction is called static friction, which is the frictional force that prevents an object from moving or slipping against another object's surface. So, this word static means lacking in movement or change. So, static means at rest, not moving. And so, static friction is the friction that keeps an object at rest, that keeps it from moving. Static friction really results from the roughness of interacting surfaces. Even apparently smooth surfaces can be microscopically bumpy. So, this person pushing against this crate on a smooth floor, it's still kind of difficult. And the reason is, even though the floor and the crate both might appear smooth, if you zoomed into their microscopic levels, then you would find that they're actually bumpy and rough. And that's what gives rise to this resistance force, this frictional force, because these two surfaces really don't want to slide past each other. It takes some effort to get them to do that. So, what are some examples of static friction in our everyday world? I love these examples because it's everywhere. One example is just walking. If you're trying to walk and you have shoes on, the shoes are hopefully providing you with some stickiness. It keeps your shoe stuck to the ground. So if you push the shoe backwards in an effort to walk, you cycle your leg backwards to move forwards. The shoe needs to remain stuck to the floor to allow the person to walk. And the only way that the shoe will remain stuck to that floor is through static friction. Now, if you had socks on, for example, and the floor was slippery, maybe there's not as much static friction there because your surfaces are smoother. But you want to keep stuck to the floor to keep moving. Another example is holding a pencil without it slipping through your fingers. If you're trying to hold on to a pencil and you're pressing down on a paper, you don't want the pen or pencil to just slip right through your fingers. You want it to remain stuck in place, and that results from static friction between your finger and the pencil. Another example that I find pretty common in my everyday experience is if let's say a cat is on your favorite spot on the couch and you want the cat to move. If you try to push the cat against the surface of the cat is stuck there because of static friction. If it's not moving and you're pushing and pushing, then that's static friction. Another example is cars. And really, anytime a car is traveling, you want those tires to remain stuck to the road and not slip or skid. But this is especially true if you park on a slope. So if you park uphill on a car, you want those tires to remain stuck there against the road's surface. And so what allows that car to remain stuck there, even though gravity is trying to pull it down the hill? It's static friction. So static friction is great at keeping things stuck or in place, but static friction will eventually fail if enough force is applied to the object. Objects will eventually become unstuck and start sliding on a surface, and that's when kinetic friction takes over. Kinetic friction is a new and a weaker type of friction when it begins acting. And another word for kinetic friction is sliding friction. So defined, kinetic friction is the frictional force that opposes the movement of two surfaces sliding past each other. Some surfaces, as I said before, are more slippery than others, and so therefore they offer less static and kinetic friction. So as an example, consider pushing this crate as we did in the first whiteboard there. As you push against the crate, it doesn't want to move. And if we tracked the frictional force over time, as you start pushing stronger, the frictional force gets stronger and stronger to keep that object stuck there. But eventually, if you push hard enough, you can break past the static friction and get the box moving. When that happens, the kinetic frictional force is actually weaker than static. It allows you to keep moving. So in this case, the maximum static friction force was 30 newtons. Once you get past that 30 newtons, you can accelerate the box, and then the friction becomes less, and it's easier to keep the box moving at that point. So let's look at that a little bit more closely with some free body diagrams, just to make it a little bit more clear. So imagine trying to push a potted plant across the floor. Okay, and this is going to be 4 instances in time. This is the beginning. This is after a few seconds, a few more seconds, and then this is the end here. So at first, when you push against this potted plant, if we represent the forces on this potted plant with a free body diagram, we of course have gravity and normal supporting the plant against the ground. But then if you're applying a force to the right and it's still not moving, it's still stuck there, then that means that there's an opposite frictional force that perfectly matches the applied force. They match each other because the applied force did not accelerate the pot, and that means that it didn't win out. It didn't overpower the friction. They were perfectly equal the whole time. And if you keep pushing harder, the frictional force will keep matching your push as long as it's stuck in place there, right? If you keep pushing and it's not moving, then you must have even more frictional force balancing it out. Let's go one step further. And again, you're pushing even stronger, and that frictional force is still matching your push until eventually you get it to move. And as it starts moving, the frictional force drops considerably. So this is the maximum static frictional force. And then once you get it moving, this is the kinetic frictional force. It's lower than the static. So it's hard to get it moving, but once you get it moving, it's a lot easier to keep it. So showing that on a graph over here of frictional force over time, the static frictional force will continue to rise and rise and rise as long as you're continuing to push on it. But eventually there's a moment where it becomes unstuck, and that's this dotted line here. And when it becomes unstuck, the frictional force will drop to a lower level, and we call that kind kinetic friction. So once you surpass the maximum static force, the object becomes unstuck and kinetic friction takes over. So that's all I've got for you in this video. Remember, happiness is not having what you want, it's wanting what you have.